Well, welcome everyone. I'm excited that you are here. We are going to get started really quickly here, and I am super excited today that I am not presenting on Anchor Standard 3, the measurement anchor standard, but that I have three people. I don't know if it's because Anchor Standard 3, but we have three people who are part of the statewide system of support for mathematics with Compass, the Compass math team here to do the presentation today. The other really exciting thing today is that all three of the people are not in the metro area. So if you've always thought, hey, what are people outside of the metro area? We have people from northern Minnesota and southern part of the state here leading us as we think about Anchor Standard 3. I'll stick around for a couple minutes at the end. Everything we're doing, you can, I'll put some links in the chat eventually if they don't, where you can find all the resources from the things we're sharing in this webinar series. So without further ado, I will let the three people, Kari, Stefanie, and Kristen, introduce themselves and get started. And thank you for being here to present for us today. And thank you to everybody that came to see this live. All right, I'll turn it over to you guys.
All right, thank you, Sarah. Again, welcome to Anchor Standard 3 on measurement. We are excited that you are here. As Sarah mentioned, there are three of us facilitating this webinar today. I am Kari Pratt, the Compass Math Lead at South Central Service Cooperative in Mankato. Kristen?
Yeah, I'm Kristen Kilpo, former middle school math teacher turned regional math coach out of the Northeast in Mountain Iron with Steph.
Hi, I'm Stefanie Biebl. I am the regional math lead out of the Northeast as well. I live just about 20 minutes south of Duluth and about an hour north or south of our cooperative. So thank you again for being here. We're really excited to see all of you here. I know summer is winding down and your time is really precious. So we're just very thankful that you're here. We're going to start with some math because it wouldn't be a math webinar without doing some math. We're going to start with a which one doesn't belong. If you haven't done a which one doesn't belong, you're looking at each of the four images. They all are labeled on the corners with an A, B, C, or a D. And you are going to find which one of these images you believe does not belong and why. There is no one right answer. In fact, I would really suggest that if you find one that doesn't belong, you look again to see if there's another that you think doesn't belong with a new reason. If you are watching the recording, you can go ahead and pause for a minute and spend some time thinking about this. If you're with us live, please feel free to either unmute or add some things to the chat. All right, looks like we're getting some great ideas in the chat. B, because there are two pencils. D, it's not starting at 0. A is measuring with cubes instead of a ruler. Trying to say, oh, C measures 5.5 inches. So it's not a whole inch length. Great. These are some great ideas. Fabulous. We just really like to start with some math and with just an entry that is a little less intimidating. Heading in, we probably have people at all grade levels here with us, and this is just a great way to start our work together today. We're going to move on, and before we really dig into Anchor Standard 3 measurement, we're going to just talk about a few housekeeping things. As Sarah mentioned, there have been 8 webinars, well, actually 7. This is the 7th, and the 8th will be next week, next Tuesday on Anchor Standard 1. The rest have all been recorded along with this one and will be up on the MCTM website, hopefully by September 1st. So feel free to go back and watch any of them. And if you really enjoy this webinar, which I'm sure you're going to, you'll probably want to go back and watch this one again as well. We also have a bunch of resources, and all of the resources for all 8 sessions can be found in one location. Kristen put the bit.ly in there. and you can access all of it. You'll notice that some of it says coming soon or in progress. That's because we're in the process of getting this all up on YouTube and all in finalized shape. So just keep checking back, and that will get updated for you soon. So again, we are Anchor Standard 3, which is measurement. And when I first heard that we are going to be in charge of Anchor Standard 3, immediately an SNL skit came to my mind. And I'm sure many of you have already seen this, but I love this skit, and we just had to include it because every time I watch it, I laugh harder. So if you've seen it, I'm sorry. If you're tired of watching it, I apologize, but I never tire of it. So we're going to spend just a few minutes watching this quick skit.
Steph, did you want to say anything else? No.
Just that I still am laughing every single time. I'm obviously very easily amused.
I'm with you. I smile through the whole thing. See if I can switch to the next slide here without playing. Come on, next slide. There we go. All right. Well, as I said, that is a hard act to follow, but it does set the landscape for how crazy our measurement systems are, and drives home the fact that our students are going to need practice with measurement, with their units, with all the different things going on. We're going to talk specifically about measurement today, which is part of strand 2, which is spatial reasoning. And this strand includes both measurement and geometry in our new standards. And it specifically states that students will actively make sense of relationships between and within geometric figures, generalize statements about the figures, and develop arguments about these relationships. So the question is, how are geometry and measurement different? They're often clumped together under the same title of geometry, but there's some very real differences. So geometry is the study of shapes, their properties, and their relationships, whereas measurement is quantifying the attributes of objects using different units. In other words, geometry provides the objects and measurement quantifies aspects of those objects. I like to think of it as geometry is what it is we're measuring, geometry is what it is, and measurement is how much of it there is, just to kind of clarify those two things. We are going to talk today specifically about measurement, how much of it there is. Our anchor standard, which reads the exact same from kindergarten through high school, reads investigate measurement using a variety of tools, units, systems, processes, and techniques in various cultures. Explain and reason with attributes, estimations, and formulas to communicate measurements and relationships effectively. Justify decisions and consider the reasonableness of measurement. There is a lot there for us to unpack. So before we can jump into measurement, we need students to notice the attributes of objects so they can eventually decide what is a measurable attribute. So attributes are features or characteristics of an item. They're the things we use to describe objects, often based on our senses, like how does it feel, smell, sound, taste. Not all of those items will always be measurable, but they are still attributes. So take a moment right now to consider this. If you met an alien who had no idea what a muffin is, could you describe it? Like looking at this muffin here on the screen, how would you describe this muffin? Normally right now I'd have you turn and talk to share some ideas, but for now, drop some ideas in the chat, or if you're comfortable, come off mute and share your thinking. I'm curious, like what are some ways you would use to describe this muffin? It's kind of making me hungry. I should have had more for lunch, honestly. And I guess if you're watching the recording, pause and think to yourself, what are some attributes or things that you would use to describe this muffin? So we're getting some things in the chat, like bread with blueberries. It's round, it's crumbly, it's sweet, it's kind of messy. About the size of a baseball. We're assuming that Alien knows what a baseball is. It's soft, it's fluffy. Those are all great words. Some of those words were measurable. Some of those things were measurable as we're talking about how big it is. Megan, thank you. As someone allergic to gluten, I often ask people to describe what something tastes like. It is very hard to describe those things. And so when we're thinking about measurement, we are thinking about the way we describe things. Some of the things we talked about, measurable. Some of them are just really great descriptions, right? And attributes are important whether we can measure them or not. So here you can see that there are attributes that are measurable and some that are not. Again, when we're talking about measurable, it has a number. It's quantifiable. And you can see the progression of learning as kids start with like length or weight, some things that they might be more familiar with, and they move up to topics like perimeter and area and volume. Maybe as they get into high school, they're talking about density. These things all have a number that means the same thing. Whereas if I look at the non-measurable attributes, again, super important for students to notice and describe these things, but also to recognize that there's not a numerical value that can be assigned to tell me how soft something is necessarily, or what it smells like. So again, great attributes, but not something that we can put a number to. All right, Kristen, I'm going to hand it over to you.
Thanks, Kari. We're going to take a look now at the 4 main buckets of concepts that show up in the measurement standard. So each of these buckets represents a concept that can be followed over multiple grade levels and through many, many benchmarks. We found as a group of us, the 3 of us, we spent some time digging into these benchmarks, and we found a lot of value in really digging into them and seeing where the benchmarks are coming from, where they're going. And we're going to give you a basic rundown of what are in these buckets, but you'd find a lot of value in digging into that yourself as well. All right, so the first bucket is money. And one of the ways that this shows up is in first grade, where students are identifying coins such as pennies, nickels, and dimes. It ramps up more in fourth grade, where they're making change up to $20. And then in high school, they should be engaging in tasks such as finding unit cost and total cost to cover area or fill volume. Go ahead and move on to the next slide. Thank you. One-dimensional measurement also spans many grade levels. For example, in kindergarten, students are comparing the length of things using words such as more of or less of. They begin to get a little bit more specific in their language, starting in fourth grade, where they're measuring to the nearest 16th of an inch. And by seventh grade, students are learning how to calculate the arc length of a sector of a circle. And then in high school, we've got kids applying dilations of scale factor K on length as well as area and volume. Another concept that progresses through multiple grade levels is two-dimensional measurement. And in here in second grade, we see this play out with students partitioning a rectangle into rows and columns of squares to find the area. And then by fourth grade, they have to be able to explain why length times width will work to find the area of a rectangle. And then this previous work paves the path for students in high school to then develop the surface area formula for three-dimensional figures. And then the final bucket is represented by three-dimensional measurement. Now, while students are introduced to three-dimensional shapes in earlier grades, it's not until fifth grade that they actually begin measuring volume using unit cubes. And then by sixth and seventh grade, they are expected to justify the formulas for finding volume of prisms and cylinders. And in high school, students deepen their understanding of three-dimensional, of applying formulas to find the volume for more complex figures. So overall, students' understanding of measurement develops progressively through these main 4 areas. And it's through this progression that we can provide a solid foundation for students to bridge the gaps for just-in-time learning and understand where they're going and where they're coming from. Now let's talk about some of the shifts that are happening within the new standards. So we're going to do a side-by-side comparison here of the 2007 and the 2022 standards. And we're going to start with how they are organized. So starting off, they are still organized by grade, just like they were in 2007. You'll notice now that the strand that was called geometry and measurement is now called spatial reasoning. And each strand has what we now call anchor standards. So they used to be called standards. Now we call them anchor standards. And that's because they really span from K through 12, not just, starting and stopping at different times. Thanks, Kari. So the spatial reasoning strand has 2 anchor standards that span grade levels K through 12. And again, if you take a look at the 2007 standards, you'll notice that they did not span all the grade levels. So they each started and stopped at different times. And in the 2022 standards, we've transitioned to these anchor standards, which progress from kindergarten through high school for nearly all of the strands. Each anchor standard also has benchmarks, just like how it was similarly to the 2007 standards. But there are some important things that we want to call out specific to the measurement anchor standard benchmark specifically. So first of all, most grade levels have new benchmarks, but second grade has the most in the measurement anchor standard at 5. So there are 5 new benchmarks in second grade for the measurement anchor standard. And then most grade levels have also removed at least 1 benchmark as well from the measurement anchor standard. And now we're a couple years out. We're not going to be testing on these standards until 2028, the 27-28 school year, but it's still good to get yourself familiarized with these shifts and with the new standards. All right, so what about telling time? What happened to telling time? If you've had a chance to dive into the new standards, you may have noticed that telling time is no longer included in the benchmarks. And this is because reading a clock is not a math concept. Okay, now we're not saying that, that's not to say that we shouldn't be teaching kids how to tell time. It certainly can and should be addressed in other areas such as classroom routines. And it also provides a really great context for mathematics as well. If you have attended other webinars, or if you were here at the beginning when we were talking about Sarah's awesome 3-dimensional 3-legged stool that she's got in the flesh, chances are you've seen this picture before. So in addition to the new standards in the front matter of the new standards, there's also this image along with the definition for mathematical rigor as the pursuit of equal intensity of conceptual understanding, procedural skill and fluency, and application. So in order for students to become truly proficient, we want to first give them opportunities to build their conceptual understanding. And that's the same with measurement as it is with other anchor standards. And this is because measurement is a foundational idea in mathematics and science, yet it's often overlooked in importance. We must help students make sense of it and not just compute it. I'm going to turn it over to you, Kari.
Thank you. So as Kristen was saying, those were several of the shifts in the standards. I want to talk about just a couple of the other shifts in the standards and highlight where those are in measurement specifically. And so in the new standards, we also have the benchmark dimensions. Dimension 1 is the standards of mathematical practice, or as we call them, the MPs. They are the things that we want our students to be able to do as mathematicians. And I always say, and just as good human beings, right? Like we want them to be able to do these things. And although all of the MPs are part of the measurement benchmarks, specifically MP 4, 5, and 6 appear the most often. The same is true about Dimension 2, the benchmark contexts. Real world context and Minnesota tribal nation context appear most often in our measurement standards. We are going to continue to learn about these over the next 2 years. Sarah's doing a webinar series on them this year that will also appear on that MCTM YouTube channel as they are happening. So from NCTM, teaching principles, they say the goal of measurement in education is not just to get an answer, but to understand what the question is asking, what tools to use, and why it matters. And I love that because it connects back to those math practices so well. Then I want to share 2 of the math practices, highlight where those really are in the standards. And so we're going to start by highlighting MP5, which is use appropriate tools strategically. And this is so important when we talk about our measurement benchmarks across all the grade levels. The tools students use will change, but it's important that they're choosing the right one for the task. And I love this image from Minnesota artist and author Ben Orlin. I mean, obviously you wouldn't flip a pancake with a hammer or drive a nail with a spatula. Like, I just love this picture. It was my favorite one of all that he did. Because we really need to ask students to choose tools that make sense for the job at hand, not only for measurement, but also just in our class, choosing manipulatives that are going to work for them in solving problems. Anchor Standard 3 measurement calls out specific tools that students should know and be able to use, especially at the lower grade levels. We need to make sure we're getting these things in our students' hands. You'll see objects to compare lengths, like those were non-standard units, rulers, yardsticks, meter sticks, measuring tapes, protractors, dot or grid paper, and unit cubes. Again, these are all such powerful tools to help kids make sense of things. The other MP we'd like to highlight is MP6, which is attend to precision. Precision is such a great word. Often we think of it in terms of being exact in our answers or our measurements, and those things are important, but we also need to be precise in our language, especially when we're talking about measurement. And again, I love this picture from Ben Orlin as we really dig into that measurement. So remember, when we're teaching children to measure, we teach them to think critically and attend to precision. And those are really, again, those life skills that we want our students to have, and measurement is such an important piece of that. So I'm going to hand this over to Steph, who is now going to take us through a measurement activity.
Now, as much as I would love for us to be in person doing this together and really doing this justice, unfortunately, when we're in a virtual setting and we're kind of crunched for time, I'm not going to be able to do this justice, but I wanted you to just have an idea of what this could all look like. And obviously, I'm not going to be able to do this for every single benchmark in Anchor Standard 3, but I did choose one that is somewhat new to the standards, and it's an addition to finding the area of a sector of a circle. Students will now also have to calculate the arc length of the area of a sector. And so what we're going to do is I am going to have you get into the mindset of a 7th grade student, if you don't mind going back there. I know that was kind of a scary time. And I'll step into the role of a teacher. And we are going to do something called Would You Rather. So here we go. Okay, class. You see on the board a picture of 2 different cakes. Both look delicious, right? But there are some differences. And one of the cakes has peeps on it. And if you don't know what peeps are little marshmallow shaped or bunny shaped marshmallows that I think you either love or hate. I personally hate them, but that doesn't matter here. The other cake on the right-hand side, or my right-hand side of the screen anyway, is outlined in Nerds Rope. And if you're not familiar with what Nerds Rope is, it is a big, big thing right now, especially with middle schoolers. They're essentially just little chunks of sugar that are colored. So what I would like you to do is take some time to think, would you rather have 1/4 of the cake that is surrounded in peeps? Or would you rather have 1/2 of the cake that is outlined in Nerds Rope? And be prepared to share why. Now, if you're watching the webinar, go ahead and pause right now. Give yourself some think time. And those of you here with us, if you wouldn't mind adding some things to the chat, or if you feel like coming off mute, that would be great as well. All ideas are welcome. Just because I don't like peeps doesn't mean you can't. Oh, it depends on the frosting. I agree. I'm kind of a frosting girl too. I would go with the nerds one as well because I just like the peeps. We're all snobs of some sort. I am a coffee snob. Oh, cream cheese frosting. If one of them had cream cheese frosting, I would definitely choose the one with cream cheese frosting as well. All right, we have a lot. If I were a 7th grader, I would just want more. I would agree with that statement. And so you're definitely putting yourself in that mind of that 7th grader, trying to count your calories. All right, so one person had mentioned that she's counting her calories, so maybe she would go with the nerds because it looks like it might possibly be smaller. All right, so thank you so much for sharing your ideas. And I just want you to know that I have actually hosted so many kids' birthday parties by this point in time in my life. I have kids, 3 kids ranging in age from 23 to 12. So I'm pretty sure I deserve a medal or a trophy of some sort for hosting so many kids' birthday parties. And I'm pretty good at it. So if you need any tips, especially on boys' birthday parties, like how to make it the most manageable birthday party, stay after and I can give you some tips. But anyway, back to this. If you are a kid, the thing you're most concerned about is getting the most candy. Like every birthday party that I've ever hosted, every kid is fighting over, I want this piece because it has that candy, or I want this piece because it has the flower, or whatever the case may be. Okay. So we're going to take a look at these 2 pictures again. And I want you to think about 2 different things now. I want you to think about if you liked both candies. So you're not going to be the candy snob like I am and think about the peeps. You're just going to think about which would give you the most amount of candy, because that's the only important part to the 7th grader, right? So which would give you the most candy and why is one of the things that I want you to think about. And I don't want you to share anything about that yet. Okay. I want you to keep that information to yourself. But what I also want you to think about is what prior knowledge that you have as a 7th grader might be helpful in proving which option would give you the most candy. So yes, we're thinking about which would give us the most candy, but we're also going to think about what prior knowledge do I have as my 7th grade self now that would help me prove which one would give me the most candy. And that's what I want you to share out about right now. And again, if you're on the recording, you can go ahead and pause and give yourself some time and come up with a list. But if you're here with us today, if you could either come off mute or add to the chat the prior knowledge that you as a 7th grader might have to help you prove which option would give you the most candy. Okay, we've got something from Becky, radius, diameter, circumference. Fabulous. We're going to definitely pull out that vocabulary that is going to be really important here. Circle formulas, definitely. Is 1/4 or 1/2 larger? So our understanding of fractions. Absolutely. Good. Yes. As a 7th grader, you would say the peeps because I would get part of the center one as well. You're right. They probably would. And the size of the peeps. Yeah, good. All right. So I'm going to kind of step out of the teacher role here now, and I'm just going to talk to you frankly about this. And what I would do at this moment in time is I would definitely spend some time talking about this prior knowledge. what do we know about radius? What do we know about circumference? What do those words mean? What do they look like? And I would document this up in front of the room, whether it's on a sheet of paper, whether it's on a whiteboard, whether it's on my document camera, somewhere for everyone to see. And then we would talk about the fractions as well. We would talk about the formulas, what specific formulas. And the reason I would do that is to activate everyone's prior knowledge, to put everyone on that even playing field as they enter into this task. We're elevating them and reminding them of how much they already know about circles to help them. And then I would give them some tools. I would give them some circles. I would give them some string, probably some grid paper. You could probably come up with some ideas as well of materials that you could leave for them to explore this problem further and have them work in teams and talk through how they could prove which would give more candy and why they could prove that. And they would have to have some mathematical proof there using the prior knowledge that we discussed previously. Then we would spend some time consolidating once they've spent some time in their teams doing some work. I would obviously be roaming around the classroom, listening, asking questions, probing them, pushing them to give me some more proof. So if you're the 7th grader who is saying the peeps are bigger, so they're going to give me more candy, I'm going to have them prove to me. Okay, well, how do you know that? How do you know for sure that that nerd's rope isn't as big as the peeps? And just ask some questions to really push them into giving me some mathematical reasoning. And then, if you wouldn't mind clicking Kari to the next screen, as I'm talking and listening to groups, I'm generating their ideas and their work. And now, one way you could work through this is what I've done in the past is I've collected different groups' work and we run through something called what's the same, what's different. And we plop up the work from the groups. I make sure that I elevate each of the groups and share with the class that this is coming from all of you, not from me. Look at the great work we're already doing. What do you notice is the same? What is different? And we have a conversation about that. Notice I'm using some color. If you're doing it on the fly, you might have to use some highlighters or use some other ways, underlining or whatnot, in order to make some of the things pop, especially if at first they're not noticing some of the things that you would like them to notice. You'll also notice we haven't talked about arc length yet. I haven't brought in that vocabulary yet. It's going to come, but we're doing this a little bit at a time, and I'm trying to really make sure that the students that are the ones who are in charge of the learning. They're the ones that are really sharing their knowledge, and it's not coming from me. So as we generalize, we look at each of the groups' work and we talk about what we noticed was the same. And then we start to formalize the learning. And that's where I really come into play. And that's where I'm a little bit more on the stage. And I would ask some questions to get them to some sort of generalized look at what are we doing here, so we can get closer to the idea of finding arc length. And go ahead and click. And we would start using, again, I'm using that vocabulary: circumference, circle, we're using fraction, and then I'm entering in that arc length. And then we have a discussion about, okay, well, what does that mean? I see the word arc length there. What does that mean? That's the amount of candy we're getting, right? The length of that portion of our circle. Go ahead, Kari. Thank you. All right, so now this is getting to be a lot. And so I'm going to start talking through this a little quicker, but I would take this a step further. Last time we used a fraction of a cake. Now I'm entering in with the degrees of the angle of the cake. And the reason I did this in 2 steps is to lessen that cognitive load. And so they're able to take control of the lesson themselves and do the heavy lifting. But again, it's not too heavy. We're doing this in steps. And we would have that same experience with letting them use some different tools to explore, work in teams, have conversations. And then again, we would go through those steps of getting to the point where we look at groups work. And then we come up with some noticings of what's the same, what's different, what's happening here, how is this different from what we did in the previous example. And we move into formalizing that formula for the length of an arc of a sector of a circle. So if you want to just click through the next couple of slides, Kari, and this is just some ideas of how you could go about doing that. There's lots of different ways. You could have groups share themselves instead of doing this what's the same, what's different activity as well. That was a lot in a really short period of time. These slides will be available. Feel free to dig through the activity. And really one of the things that I just want to take the time to highlight is, obviously this is just one benchmark, but thinking about rigor and thinking about the math practices and making sure that our tasks in our classrooms are rich with those pieces is really important. And that was really what I wanted highlighted here, more than just the fact that this is one of the benchmarks out of our measurement anchor standard. And then I'll pass it on to Kristen, because you've heard enough from me for a while.
Thank you, Steph. Steph mentioned that you have access to this presentation, or you will. And I just shared once again the links to these resources in the chat, so you can access if you want to go through her example a little bit more in depth. But I do want to take a moment to talk about the different ways that Steph provided opportunities for kids to build their conceptual understanding of arc length. So go ahead and click next, Kari. Thank you. So first of all, she provided us with a context, something that we could connect with, and a visual to make sectors of circles really come to life for us, and something that is relevant and engaging for kids. We all know how, I'm thinking of middle schoolers because that's my background, but elementary kids and high school kids too, who doesn't love a good piece of cake. She also encouraged us to think of the different ways that we could model or represent our ideas, whether that be with models, go ahead and click, in words or equations, and instructed us to use these as a way to help us show our thinking and help build that conceptual understanding and justify and explain our thought process to someone who might be looking at our work. And when she was having, looking at the different equations and having us generalize to a formula, bringing in those different ways and showing how they all connect together. And that consolidation piece is so important. So it's through these key teacher moves, that we can really provide students with opportunities to build their conceptual understanding and then develop the standard algorithm to then move them towards that procedural skill and fluency. Go ahead and hit next slide. So how could we connect this activity that we just experienced to other grade levels? So calculating area and arc length of a sector might be a 7th grade benchmark, but there's a lot of work that's happening in previous grade levels that provides the scaffold for engaging in those skills, such as calculating the perimeter of a polygon in grade 3, or justifying the formulas used to find area in 5th and 6th grade. In addition, the work that is done in 7th grade is laying that groundwork for students to engage in developing the formulas for surface area of 3-dimensional figures in high school. And a key piece that I want to call out with this is that students are not just expected to perform calculations. So this is not just, let me give you the formula, you memorize it, you calculate for me. Kids need to be able to apply, develop, justify, and explain why those calculations work. And you see we pulled those words right out of those benchmarks. They're really key here. In the cake activity, we could have just provided students with the formula for arc length of a sector, but instead we provided them with experiences where they could develop that formula through scaffolding. So we cannot just focus on procedural skills only, but provide students with experiences to develop that conceptual understanding first. That's actually bringing us to the end here. Maybe I'm just a fast talker. We really want to, as we wrap up today, we want to thank you for joining us, especially in the summer, as we took a closer look at Anchor Standard 3. So we're going to take a moment to talk about a few key takeaways here. So first of all, measurement deserves the spotlight. I think this is a phrase I'm stealing from Kari here, but I really like it. It's more than just geometry's sidekick, right? Understanding attributes, units, and precision helps students build deeper mathematical foundations that supports both geometric and algebraic thinking. And also, a second takeaway, the new standards guide our students through the progression of learning, focusing on 1-dimension, 2-dimension, and 3-dimensional measurement. And finally, by connecting mathematical rigor, the math practices, and providing context for students, we're building that deep learning. And remember that memorization isn't mastery. Just because a student has a formula memorized does not necessarily mean they have the conceptual understanding of that formula. So we really need to create meaningful learning for students that helps them understand and derive formulas, not just memorize them. So as a reminder, this information is available for this session and all of the sessions around the Anchor standards. I'm going to go ahead and put it in the chat one more time here. You will find the recordings on the MCTM YouTube channel. I think most of them are already up. I think the rest are supposed to be up around September 1st. And also we want to share with you, go ahead to the next slide. There's a calendar for all things Minnesota math for this upcoming school year. You can use the QR code to access it, or I believe someone might be able to put that in the chat for us as well. So I encourage you to bookmark this page. There is so much happening this year, and bookmark that and find that as when you're trying to do some extra learning. And finally, we just want to say thank you so much for your time, and we hope you have a fantastic start to your school year.
Thank you, you guys. Like I said, I'll stick around and have a conversation with anybody that wants to talk, but I am super excited that you could join us today.